right, in this video, we're going to talk about inverse trig in the unit circle. I know that I have a video up that talks about finding specific values of sine and cosine when looking at angles within the unit circle. But now we're going to kind of work backwards. We're going to look at the inverse trig in the unit circle. And so we need to remember just a few quick things. Remember that sine of theta represents our y values. Cosine of theta represents our x values. So depending on what your problem has, that's going to dictate where and what coordinate you're going to look for on the unit circle. Now, the next thing that we have to do, that's kind of the first big thing, and then finally the second big thing that we need to know is that the inverse of sine exists only from negative pi over 2 to pi over 2. All right, so when you're looking at the unit circle, we get that the inverse of sine only exists within these two values. And I'll explain what that means when we start seeing the examples in just a moment, but whenever you take the inverse, you're going to wind up with two angle measurements, all right? When we take an inverse, we get angle measurements. So when I take the inverse of something, we get angle measurements. I need to make sure that they're going to fall within these two bounds for sine. Same goes and is applied for cosine. Cosine, the inverse of cosine, exists only from 0 to pi. Or, and for both of these, if you're in degrees, which we're always kind of working within radians now, 0 to 180 degrees. And then obviously over here would be negative 90 degrees to 90 degrees. So keep that in mind. So with cosine, our values are only going to be in existence if we are in these areas here. So with that in mind, let's go and jump into some of these examples. Now, you need to be very familiar with the unit circle when we start jumping into these. I know that, again, depending on what I'm looking at, cosine represents my x values, sine represents my y. So let's look at question number 1 and go ahead and start looking at these inverse functions. So I have the cosine, the inverse cosine of root 2 over 2. So in my head, what I'm doing is I'm thinking of my unit circle, and I'm thinking of all of the places that I have an x value of root 2 over 2. I know that I have a x value of root 2 over 2 at pi over 4. And then down here at 7 pi over 4. Now, sorry, shouldn't be equals. Only one of those answers actually occur within the bounds of cosine, which is up here. And that answer is pi over 4. So that's what I mean is we've got to look to see what answer, what angle measure works within the bounds that we have. So if we keep that in mind, all of these problems should be very, very easy. So looking at example 2, sine of 0. So again, I'm looking at my unit circle, and I'm thinking, okay, at what angle measure do I have sine that gives me 0? Where is my y value where I have 0? And I have that actually in two different places. I have negative 1, 0, and then I have 1, 0, and that occurs at 0, and it occurs at pi. Well, again, what's within the bounds of sine? Well, here, it's 0. All right, so we're going to continue that trend. We're going to start thinking about those kinds of things as we look through more of these. So jumping straight through, the inverse cosine of negative 1/2. So again, when I'm looking in my section here just up top for cosine, what value gives me a 1/2 for my x value. Well, that's going to be right there at 2 pi over 3. Okay, using my unit circle, I'm just looking for where I have an x value within that upper bounds up here, where I have an x value of -1/2. For sine, I'm thinking, okay, well, where do I have a y value where I have -√3 over 2? Well, that occurs right here, where I have a +1/2, but a -√3 over 2, and that occurs within my bounds of sine at right up here, -pi over 3. And finally, our last problem here is the inverse tangent. Now, we didn't talk about that up here with our original rules, but remember, the tangent of theta is simply sine of theta over cosine of theta, or y over x. Now, if you're familiar with your values of tangent on the unit circle, when I'm looking for tangent, so the y over x, you should be familiar with whatever the values here of y over x would give you. Now, I know that on the unit circle, I get the value of √3 over 2 right here at the value of pi over 3. And so we are going to write in pi over 3. And that's it. Tangent's a little weird. Check out my video on tangent within the unit circle for more questions on that one. I really wanted to focus on just cosine and sine on this one, but I got a little ahead of myself. But for at least 1 through 4, and look at that. Look at this math teacher that can't even keep up with his numbers. What a big old loser. But anywho, hopefully 1 through 4 made a lot more sense to you, and you feel comfortable with finding these inverse angle measures within the unit circle. So hopefully you guys feel much better on this. Thanks for checking out the video. I'll catch you next time.